Good morning. Mr. Herman here with the beginning of our Unit 2. Unit 2 is about something called trigonometry, which sounds really complicated, but we're going to work through the next few weeks to kind of simplify what that is and break it down into all of its components so that we can use trigonometry to do something we call solve right triangles. So we're going to kind of think about what we had last unit with our triangles, and we're going to move into working with some more things, add some more stuff to it with our right triangles. So we'll start off with a quick review of our right triangles, as well as introduce some new things of right triangles, and recalling how we find angles in a right triangle. There are 180 degrees in a triangle, and there are 90 degrees in a right angle. The two triangles that are not the right angle will add up to 90 degrees. So if we have a right angle 90 degrees, the other two angles are going to be 90 degrees together, and we call those complementary angles. Okay, that means two angles that add up to 90 degrees. So how do we find the sides of a missing angle in a triangle? We saw this a little bit in Unit 1, but we're going to go ahead and formalize it here. We can do 180 degrees minus the other two angles in the triangle. Okay, so done a little bit, we'll do it a little bit more. So if we're trying to figure out how big angle C is, we know that this right here, 90 degrees. This is a right angle symbol. We see that when you think 90 degrees. So I'm going to do 180 degrees minus 90, gets me 90 degrees. And then 90 degrees minus my other known angle, minus 25 degrees, gives me 65 degrees. So that means that angle C equals 65 degrees. All right, so we've done that before, so just a quick review of that. Now, is this a right triangle? So a similar idea, but asking a little bit different question. So we want to go ahead and solve for angle H up here. So let's go ahead and do the same idea. So 180 degrees minus 56 gives us 124 degrees. And then 124 degrees minus 32 gives us 92 degrees. Okay, so is this a right triangle? No, because this angle is 92 degrees. So angle H equals 92 degrees. No, because angle H does not equal 90 degrees. So if it equaled 90 degrees, we're good to go. But since it's not equal to 90 degrees, this is not a right angle. It is not a right triangle. So that should hopefully be review. Let's go ahead and do a little bit of new things that we'll see throughout this unit. We call this labeling sides of a right triangle. Okay, so when we're working with right triangles, we have this right angle in every triangle. We also have an angle that we're going to call the reference angle. Now, this is a fancy Greek letter that we'll see a lot with angles, and we call it theta. Okay, so kind of like a zero with a line through it. Now, we name each side based on this reference angle. So our opposite side is across the triangle from the reference angle. Okay, now our adjacent side is next to the reference angle and the right angle. And then our last side, our hypotenuse, which hopefully we've heard before, is across the triangle from the right angle. So let's go ahead and label our sides here. So I'll start at my reference angle. That's my angle that I'm using. I go across my triangle, and here's my opposite side. Now I want to find my adjacent side. It's next to my reference angle, and it's next to my right angle. So it's going to be this side right here in the middle. My adjacent side, and then in purple, across the triangle from the right angle, there's my hypotenuse. Okay, so let's go ahead and label our other triangle. We'll start with our opposite side. So here's our reference angle. I go across my triangle, opposite. I go, here's my reference angle, my right angle, it's in between. Here's my adjacent side. And then let's go across from our right angle for our hypotenuse. Okay, so we'll do some more work on labeling these sides throughout our unit. So now we're going to bring back a little bit of review, and we're going to remember one of our favorite equations. And our favorite equation is the Pythagorean theorem. So the Pythagorean theorem is going to be a squared plus b squared equals c squared. Okay, so we talk about two types of sides here, the legs and the hypotenuse. So we've seen the hypotenuse already. Okay, so let's think about the legs. So the legs are the two sides that touch the right angle. That's going to be A and B. And then our hypotenuse is the long side across from the right angle. That's side C. So there's a couple different things we might have to do when we're solving Pythagorean theorem. We might have to find the hypotenuse side, or we might have to find the leg side. So we're going to start with finding the hypotenuse side. So I'm going to go ahead and label all of my sides first. So I'll say this is A, this is B, this is C, and then plug into my equation. So I have 6 squared plus 8 squared equals x squared. Do a little simple calculation. We can use the calculator on these. 36 plus 64 equals x squared. 100 equals x squared. And then in order to do the opposite or the inverse operation of x squared, hopefully we've done this before, we want to do square root. And so the square root of 100 is 10. Now if we want to find a leg side, we're going to take the same approach. Okay, so I'm going to say that A equals 4, B equals x, C equals 12.5. And then I'm going to plug in. So I have 4 squared plus x squared equals 12.5 squared. Use my calculator to get 16. Hopefully we could do 4 squared without a calculator. But 12.5 squared, definitely need a calculator there. Gives us 156.25. Now before I do the square root, I want to get x squared by itself. Okay, if we notice above, I got x squared by itself before I square rooted. Let's get x squared by itself. So take away 16 on both sides. X squared equals 140.25. And now I have x squared by itself. Let's do the inverse operation and square root. So x is approximately 11.8. Once again, I would put that in my calculator as well. So the last part of what we've got going on today is this idea of solving a right triangle. Okay, now we're going to pick up some tools as we go through this unit to solve right triangles with less information or different information. But solving a triangle means finding all angles and sides. Okay, so we had to figure out what are all of our angle measures, what are all of our side lengths, in order to solve a triangle. So if we look at this triangle here, we know the 35-degree angle. We have a right angle over here. We want to find angle B. So let's do our angle first. So 180 minus 90 is 90. And then 90 minus 35 gives me 55. Okay? So 55 degrees is going to go right here. Now we need to find this missing side length. Okay? So let's go ahead and say that if I have two side lengths, I'm going to use the Pythagorean theorem here. So I know that A equals 12, B equals X, and C equals 47. So let's go ahead and plug into our equation. 12 squared plus X squared equals 47 squared. Break out the calculator. And then, of course, 2209 is 47 squared. Then once again, we want to get X squared by itself, just like we saw before when we were finding a leg. So minus 144 on both sides. That's going to give us 2065. X squared is by itself, so you can now square root. And then X is going to be approximately 45.4. Okay, so we've just solved our first right triangle, and throughout the rest of the unit, we're going to be finding more strategies to solve a right triangle. But now, let's go ahead and do the couple of practice problems for solving right triangles using the methods we have so far.